Okay, so here is the circumference activity spreadsheet that most of you have filled out. A few of you haven't done so yet, and that's okay. I'm just going to go ahead and work with what I have here. I think we have plenty of observations that we can use. Um, so I've erased your names. Some of you put your names over here, which I appreciate, but I erased them because I didn't want to embarrass anyone in case I make fun of some of in case I make fun of some of your observations. But it looks like we have some really good data here. We have some really great observations, and we also have a couple kind of not so good ones. That's okay, but the idea in this activity, just to refresh your memory, is that, so I asked you to find a circular object somewhere around your house or whatever, and then measure the diameter of the object, and then measure the circumference of the object. And so some of you down here, I think, didn't do that. I could be wrong, but I feel like some of you down here, like I don't know how you get 43.96 so perfectly unless you used a formula to find that circumference, which is not what I asked you to do, right? I asked you to measure it, right? I asked you to measure it with some measuring tape. But anyway, we'll go with that. Now the main point, the main thing that I wanted to drive at through this activity was, if you look at this column here, where I asked you to compute the ratio of the circumference to the diameter, you'll notice that all of these numbers are pretty close to the same. There are some outliers, like this one right here, 1.794. I'm not sure how that happened. I think there were probably some bad measurements here where you maybe weren't quite as careful as you should have been when you were trying to measure. 4.18 is a huge kind of, it's much bigger than it should be. So a couple of these, you know, are maybe not so great. But for the most part, we're around 3. We're like somewhere between, you know, 3 and, you know, 3.25 or whatever. So, so we're all kind of right in that ballpark. And in fact, I'm going to do something, and I've never tried to find the average of something in Google Sheets before. I've done it in Excel, but in Google Sheets I've never done this before. But I'm going to try. So I'm going to try to find the average, and then I'm not sure exactly how I need to do this. It says example, average A2 to A100. Well, I want to average D4 to D32. So I'm going to type in D4. D4 to D32. Let me see if that works. There we go. Okay, good. So that kind of worked. So this is the average of all of our observations, right? So it's the average of all of the ratios of the circumference to the diameters that we measured. And if you look at this number, now this is 3.131208, blah, blah, blah. That's awfully close to another number that we all know and love, called pi. You may have heard of it before, right? But pi is about 3.14, right? And so we're pretty darn close to that. In fact, so these individuals got exactly 3.14, and it's like I said, it's because I suspect that they didn't actually measure. I think that they used formulas to get from here to here. And if you use the formula, then of course, when you divide these things, you're going to get pi. That's kind of missing the point of the activity, though. Right? The point of the activity was to measure the diameter and the circumference to prove that the ratio of the circumference to the diameter is in fact pi. And it is. You know, we're getting something pretty close to that. If we were more accurate with our measurements, then we would see that, yeah, we're right on the money. 3.14, right? The ratio of the circumference to the diameter is, well, not right on the money, but it's about 3.14. It's pi. It's equal to the number pi. So that was the purpose of the circumference activity. And in another video, I'll walk you through why that's important, why it's important to know that the ratio of the circumference to the diameter is pi. But basically, it gives us a way to be able to compute the circumference of a circle, right? Because remember, if we're working with squares or triangles or whatever, it's easy to find the perimeter. You just add up the lengths of the sides. But if you have a circle, how do you do that? Well, if you know the diameter, then you can solve for the circumference, because you know that the ratio of the circumference to the diameter should be pi. And I think that, just real quick, just let me say one more thing. I think that that's a pretty cool thing, right? Regardless of the circle that you start with, regardless of how big it is or whatever, if you measure the circumference and then measure the diameter and divide those two things, you're always going to get the same number, right? 3.14, assuming that your measurements were accurate. So anyway, I think that's pretty cool. In the next video, we'll derive a formula for the circumference, and then we'll look at some example problems.